So I'm going to quickly talk you through the 3D workflow that I came up with to edit the short film The Hub. The main focus of this workflow was to be as cheap as possible for low budget filmmakers, but also to be able to be applied to higher budget features. Now the biggest problem we faced on this film was that we were shooting with unsynchronized cameras, so the time codes didn't match, the frames didn't match, and this all had to be fixed in post-production. Now before I get any further, I'd like to say a big thank you to Sophie Peterloo, who is responsible for the production of this film. She designed the custom DIY 3D rig that we used, and without her this project would never have happened. I'd also like to make a quick disclaimer before we get started that I'm not saying that this is the absolute best way of editing 3D, and I'm not saying it's the only way of editing 3D. It's just the method that I used and worked relatively well for me. It didn't work brilliantly. There's a lot of things that could have been sped up, but I thought I'd show it to you and maybe you get some feedback on it. So the first step is to import our media files into Final Cut Pro 10. And the method I like to use is to create a virtual disk image for each project. Then inside that disk image have multiple events, one for each day, and then import my media into there. Now there are two ways to get your media into Final Cut. You can either copy directly off the camera's cards, or copy the cards onto a hard disk and then import the files from there. If you choose the second method, make sure you put your files into folders called left and right, and then when you import, select Import Folders as Keyword Collections. And that means that the files are automatically tagged with either the left or right keyword when they're brought into Final Cut. If you import directly off the camera's cards, in the import dialog in Final Cut, just set the camera name to left or right depending on which camera it was. Now we've got our media into Final Cut, we want to start organising it. And the first thing we need to do is to assign roles. So to start with, go up to Modify, Edit Roles, and in your video roles you need to create two sub-roles, left and right. To create a sub-role, just click the little plus at the bottom and type the name of the sub-role. If you need to delete one, just select it and press backspace. Then click OK when you're ready. So in your left keyword collection, select all your files and do assign roles left, and in your right eye, select them modify assign roles right. And these roles will be used later when we do the export, and you'll start to understand why we've taken that step. Next up, we need to add scene, take and angle metadata to each of our clips. Now this is really easy to do. If you had a clapperboard on set, you can just read the information right off it. And for the audio files, you need to listen to what is said before recording. And you need to go through every clip and do this. There are a few ways of speeding it up, like if you select two clips that are in the same scene, you can bulk apply the scene metadata to it. So you need to go through this for each clip of each angle. And when you've got a big project of over 100 clips, this is what can take a really long time. Now the reason we assign the metadata is so that we can easily match up the left, right and audio files from each take. The next step is to use the metadata to actually search Final Cut to find the three files that are relevant to each take. Now the first way to do this is to create a smart collection, and in the filters create three filters using the format info, one to get the right scene number, one to get the right take number, and one to get the right angle name. Once you've done that, you should hopefully see only the clips that are relevant to that search. If you see more or less, then you know you've made a mistake and you need to go back and double check what you've done. But in this case it's right, there's no audio file, so we should only see the two video files. So we're going to just do right click, synchronize clips, and Final Cut's going to handle the rest. The other method is to simply use the event browser to see at a glance which clips match up. So here we've grouped the clips by the scene, and we're displaying the take and angle name right inside the browser so that we can easily pick the clips that match up. And again, we're just going to let Final Cut synchronize them. Once Final Cut has finished synchronizing, we need to find all our synchronized clips. The easiest way to do this is to create a new smart collection and have our search filter be for the text sync. And this will show us all our synchronized clips. We're then going to open each of the synchronized clips in its timeline and double check that it's synchronized accurately. So you can see here the left and the right eye clip on top of each other, and here we're going to use the clapperboard to help us make sure that we've got a decent synchronization. And you can see there the audio waveform was slightly out, so I adjusted it to be closer. And then we are going to trim the clips to the start of the clapperboard, and then trim the tails of the clips so that they're exactly the same duration. And that's a really important step. After we've done this, we need to apply the scene take and angle name metadata to the clip again, and we're going to use this to rename the clip later on. We also need to change the starting timecode of the clip. This is because Resolve identifies clips based on their starting timecode, so if they're all at 0, it's going to get really confused. So for this project, I changed the starting timecode of the clips to be the time of day that the shot was taken. Once you've done this with all the clips, you're going to want to apply a custom name. The first step is you need to create the filter that you want your name to have. So you click on Apply Custom Name and click on New. Now you can build up whatever name preset you want, but for me I chose Scene, Angle, Take. Quite simple. So now you need to select all your clips in the event and do Apply Custom Name and select your naming filter. Now you notice that all my clips have disappeared from my Smart Collection. That's because it was searching based on the name of the clip. The best way to avoid this happening is to keyword tag your synchronized clips with synchronized, and then they'll always stay in that collection. Now that we've synchronized our clips, we want to export them from Final Cut. And this is where those roles we used at the start come into play. Because Final Cut lets us export different files depending on the roles in the video. So in our synchronized clip, we have one file tagged right, one file tagged left. Now when we go in our export settings, you can see that at the bottom, we can export our roles as separate files. Okay, so we're going to export everything tagged with left as one file, we're going to add another file with everything tagged as right, and then all our audio is going to come out as a separate file. What you end up with when it's exported is 3 clips: your right eye video, your left eye video, and your audio track. And they're all named in a really sensible way, they have matching timecode, they're the same duration, the same format. It's perfect for what we need when we come into Resolve. It's important to note that everything we've done so far was only because we were shooting with DSLRs rather than cameras that could genlock. If we had cameras that could genlock, we could skip the whole process and jump straight into Resolve and import the files directly. But instead, we needed that process of creating perfectly synchronized files of matching durations with matching timecodes, because that is how Resolve handles 3D. And now we're in Resolve and you can see my exported media there in the browser. Now a really important note is that for any scene that has dialogue or synchronized sound, you need to make sure that you export the audio from Final Cut as a WAV file, and then inside Resolve you need to link up your left eye to that audio file. Otherwise later on when we export the dailies for editing, you're not going to be able to hear what any of the actors are saying. So now we've got all our media, the next step is to import it into Resolve's media pool. But first we need to create 2 bins, one for the left eye and one for the right eye. Now it's really easy in Resolve to actually import the files that Final Cut exports, because you can use the search window in the top right there and search for left, and it'll show you everything that was exported with the left role from Final Cut, change it to right, and it automatically shows you everything with the right tag. And that's a really easy way of making sure that you're getting the right files into the right bins. Now before we go too much further, we want to fix the fact that we shot using a mirror rig, meaning that all our right images are flipped horizontally. To do this we go into Clip Attributes, Image Flip, Horizontal, hit OK, and there you go. Without rendering, it's flipped everything, and now we can start working on it. The next step is to create a stereo EDL, and to do that we right click on the master bin and click Generate Stereo EDL and save it to our hard disk. Then over on the Conform page we want to go up to File, File, Import XML and click our stereo EDL, hit Open, automatically set the project settings, let's call it Left Dailies, and importantly we need to uncheck Master Bin and check just the Left Bin. Now we're going to do it again, bring in the same EDL file, this time we're going to call it Right Dailies, automatically set the project settings, hit OK, and this time we're going to select our right bin. This now means that we've got all our left files on one timeline, all our right files on another timeline, with the clips in the same order. This means that we can go ahead and set the left timeline to be stereoscopic left eye, and the right timeline to be the stereoscopic 3D right eye. And now over on the colour page, you can see that our 3D view has become active, and that we can select our output to be anaglyph colour, and now you can see that we have successfully got our left and right eye files there. Now you can see from the anaglyph view that at the moment you wouldn't be able to look at that in 3D because there's just too much parallax between the image, and this is because we shot using a parallel rig. But the next step is to 3D groom the images so that during offline editing the editor can actually watch them in 3D without getting a headache. So here we are a little later on in the clip, and I'm going to set the viewing mode to difference, and that shows us the difference between the two images. And here you can see the parallax between the houses in the background and the people in the foreground. Now the first step that we're going to do is set the convergence so that we've reduced that parallax as much as possible. So down in the 3D viewer, you see the convergence. We're going to click that little link icon that means that Resolve will zoom in for us as we converge, meaning that we won't end up with any black space at either side of the image. Now we're going to keep going until we've set our point of convergence, which in this case is the pavement in the very bottom of the screen, which is about there. And you can see that the image has got much darker as the difference between the two images has been reduced. But you can see there is some vertical displacement and rotational displacement there, and this is where we're going to use the tools inside Resolve to reduce that. Now the first one we're going to use is the transformation tool, and that's going to automatically analyse the image and adjust it as best as it can to make sure that it's just a horizontal parallax. You can see here it's done a pretty good job on the anaglyph view, but the colour isn't perfect yet. So if we look at the side by side, we can see the right eye is bluer and the left eye is more pink. But that's okay because inside Resolve there's another two tools that allow you to match the colour of 3D clips. One of them uses primary controls to do this, and the other uses secondary controls. For this clip I'm just going to use the primary controls, and you can see there it's matched them up pretty well. Once you've done this for all your clips, you're going to go ahead and go onto the Deliver tab so that we can render out the offline clips for editing. So here we're going to use the settings, and we're going to set it to render out a H.264 file at 1080p, 25 frames a second, basically all the same settings that you've used before. We're going to render out each clip as an individual source clip rather than rendering out the whole timeline as one long clip. Just going to select the location. It's best to make a new bin called offline material so that you can keep the offline clips separate from the online clips. Then you need to set it to use the source file name of the clips. And then you need to enable 3D stereoscopic rendering and select the mesh option to side by side. This means we'll end up with one 1080p frame with both the left and the right eye views squashed into it. Once that's done, you need to add the job and hit Start Render. Once it's done rendering, we're going to open up Final Cut 10 again, and we're going to import the offline files that it rendered out. Here you can see the side-by-side format inside Final Cut, and this is our method to editing 3D inside Final Cut, which can't itself natively support 3D. So let's import all those files. And here's the secret sauce that makes editing in 3D in Final Cut possible. You can see here that Final Cut thinks these clips are just standard 2D files, which means that I can skim through them, I can edit them, and there's absolutely no impact on the system performance. And most importantly, Final Cut's not doing anything to work with these 3D files. However, my external monitor is a passive 3D display, and that's taking this side-by-side footage and converting it to an interlaced format that then works with its 3D glasses. This means that I can edit as if it was a 2D film, but be monitoring in 3D. And this means that I'm not going to make any edits that might cause an uncomfortable 3D experience. Now I'm just quickly putting together a 3-edit timeline here, just to give an example of the next steps after we've done this. So once we've done that, into our project, we're going to go back to the project viewer, select the project, and do File, Export XML, and choose a save location. Over in Resolve, we're going to import those XMLs, as Resolve is able to natively import Final Cut Pro 10 XML. I'm going to hit Open. We're going to disable automatically import the source clips, and we're going to add left to the end of the sequence name. Then when we hit OK, we are going to select just the left bin to find the source files in. And then we're going to do this again. In File, Import XML, import the same XML, disable automatically import clips, add right to the end of the sequence name, hit OK, and then select to conform from just the right bin. Now if I zoom in, you can see that Resolve has automatically linked my edit back to the original right eye files, and in the other one to the original left eye files. See how easy it was? That's all thanks to the fact that the time code was unique for each clip. So now we're going to set the left eye to be the stereoscopic left eye and the right eye to be the stereoscopic right eye. Now the good thing is that Resolve has saved all those settings that we made to it earlier before we went into the offline edit. So if I go on the difference view here, you can see that I still have that nice clean dark image because the convergence is the same, the colours are the same, and the transform is still there. It's not burned into the image, I can still change it at any time, but Resolve has managed to transfer it from the original timeline to the new timeline. So now the next stage we need to go through is creating the grade. So I'm going to change the label on the first node to be stereo fix. I remember that's where Resolve has stored its colour matching information. And then I'm going to add new nodes outside of that where I can apply my creative effects. Now the important thing is that you grade in 2D on either the right or left eye, and you leave the ripple link button enabled, which means that any changes you make to one eye automatically ripple across to the other. Now the reason that we grade in 2D is so that we can focus on the colours of the images and not get distracted with the depth information just yet. Now I've done a quick grade now on the left eye, which involves 3 different nodes, and now to check it ripple properly we're going to go across to the right eye, and you can see that the same nodes are there. Now we need to compare the colour to make sure they're the same, and you can see they are not the same. So what we're going to do is we're going to add a node, correct a node, and we're going to add it in front of those grades, just there, after our first stereo fix node. And we're going to use the same automatic colour matching tool we used before to match the graded colours back up. And you can see now they look much more accurate. At this point you need to go back through your project to make sure that all your 3D settings are spot on, and even add some 3D grading if you want, adding different colours to bring out or push objects back in the scene. Once you're happy with your finished grade, we're going to go over to the Deliver tab and select the Final Cut Pro XML round trip preset, but this time we're going to disable stereoscopic rendering. The reason that we're going to do an XML round trip rather than exporting the whole sequence as one file is because if we want to make changes later on to a specific clip in the grade, we can just re-export that clip rather than re-exporting the whole sequence. Now you're going to have to do this export twice, once for the left eye sequence and once for the right eye sequence. So back in Final Cut Pro 10, we're going to import those sequences from Resolve and turn them into compound clips, which I've already done here. As you can see in the event browser, I've got my left eye compound clip and my right eye compound clip. Now I've also created an online master compound clip, and in here you can see that I have the right eye compound clip and the left eye compound clip with the finished graded clips from Resolve. Now in order to export this out as a 3D file, I built a custom plugin using Motion that enables me to set 3D view settings. So if I select the left eye file, I can make it a side-by-side left file, then select the right file, and I can make that a side-by-side right file. Now you can see that I've made a side-by-side 3D file inside Final Cut, which I can then upload to YouTube and it will be able to interpret as 3D. I also did the same thing with my credits, so I duplicated my credits on top of each other, then selected the top credit and assigned that to side-by-side right, and then the bottom credits to side-by-side left. And there you go, that is the whole end-to-end process for how I carried out the 3D post-production on the hub. As you can see, at times it's quite a long-winded method, especially when we were dealing with unsynchronized files. But I hope it's given you some food for thought, and it's definitely a relatively cheap way of editing 3D, as it costs less than £1,000. If you've got any further questions about the workflow or anything else, feel free to contact me with the details on your screen now. Thanks for watching, and goodbye.